had to get out and ask somebody not to park directly next to me, so that worked out pretty well. So you can see we're actually up to 1200 degrees right behind that cat. And we're at 1100 all the way down the line now. So let's see where we are, because that was a couple of minute delay there. 36% on the treatment injector. Down to 17 grams. Yep. Just burning it all out, so we're good to go there. Piece of cake. 1 PSI difference across that particulate filter and 1.27 volts. So that's going to keep coming down, and the soot mass is going to go all the way to 0 to 3 is usually what I see, and then it'll kick out. So we're almost there, down to 15 grams. The other thing that this usually does is it'll quit burning off, and then it'll go into a cool down mode where the engine RPM will stay high, but it will turn off that injector, and it will just flush hot exhaust through that exhaust system until it brings down all these EGTs to a normal range. And when I say normal, I mean right about in this neighborhood, whatever we're seeing come out of the turbo. So, yep, you can see here where we're up over 1100 degrees, and now we're really cooking. So that's good. The nice thing is, most of the time, this happens while you're driving around on the street. So as a result, you don't really even notice it. The key is to know when it's going on. And if it's going on, it's better for the truck if you just go ahead and drive it until it's finished. So I actually had that happen this past year as I was getting an emissions test. I drove over to get the emissions test, and the truck went into a regen mode. Luckily, I was able to walk in and tell them that, and then I went ahead and drove it for another 25 or 30 minutes, and it finished its regen, and then we were able to put it on the emissions machine. So, because I went in and asked the specific question, I said, have you guys seen where that causes an issue with the emissions test? And they said yes, they had. So here we are. We're down just below 1 PSI, and we're at 10 grams. Now we're at 9 grams. So we're going to be done with this here really shortly. That happened really quickly. So basically, the ones that I usually play with, I'm used to playing with at work, have 60 grams or more, and that will require more than one regen as a rule. So as a rule, you don't need to run it that long to get it to do its regen. So, and part of the reason that I really didn't get a complete fuel tank out of this before it was regenning again was the fact that I was towing with it. So, and had I kept towing, I'm sure that it would have just dumped some more fuel and gotten plenty hot, and that would have been the end of it. But I was looking over here too. You can see right here where during the regen, our NOx is pretty high, right? So, and we do have O2 concentration that's higher going in than coming out. So at that point, we know we're actually forming NOx because we have 141 going in and 176 coming out. So what that means is once we get it up to 1,000 degrees Fahrenheit, there's really not a way to get rid of that NOx. So it looks to me like they just sort of ignore it during a regen, which makes sense. I mean, I'm not really sure. The problem is if you start spraying a bunch of DEF in there to take care of it, that can actually have a negative effect on the regen. I have had some situations where the DEF injector has dumped a bunch of DEF in there, and we actually have to do a regen to burn everything clean before we can do a reductant test. And a reductant test means that you're testing the quality and ability of the DEF and the DEF injection system to get rid of NOx. So obviously we want that to heat up. We want it to burn off right now, so we're not even trying to control it. We may have been earlier, but we're not doing it now. So now we can see that all of this has updated to zeros, and when we get done, that's probably going to say 125, because we're doing that right now. We're down to 5 grams of soot, and HC injector is still working. Everything is up over 1100 degrees, so everything is cooking with gas, and we are almost done, so that's great. So depending on what happens, I didn't bring my stuff today, but I'll probably change the oil on the truck tomorrow, because I'll be back here at the school doing a catalytic converter diagnostic demonstration for you guys. So that'll be my work for the day. I'm gonna go home and do a video on chapter 12 for you guys, and then upload that, so that'll be exciting. You guys can have a discussion on that. And I've been making some other videos that I'm going to go ahead and upload as well. So we're still running that injector. We're still up almost to 1200 degrees, which is good. A lot of times if that injector is not working, what you'll see is 700 or 800 degrees here at the EGT sensor. And what's interesting too is there's a volume specification for that injector. Every time I've tested one that's been bad, it's been right on the bottom of that actual specification. It's like 16 to 34 milliliters of fuel that it's supposed to inject during its set time. And every time it winds up being right on 16, so I always wind up replacing the injector. And I've never had a comeback with that. Those injectors, 13s didn't do it nearly as often, but the 11s and 12s are kind of prone to it. The first 2 years of production. Not saying that they changed it for 13, because they may not have. But it just doesn't seem like 13s are that prone to it. So, at any rate, we're down to 1 gram, 0.9 psi. So what that shows you at 0.9 psi is that there is some, now that we're at 0 grams, there is some inherent restriction anyway, and that's why we don't need the muffler anymore on a diesel. We got rid of it when we put the DPF on. So way back in 07 and a half, when we went to the DPF system, even without the DEF system, we got rid of that muffler, and it's all gone because we don't need it anymore. Diesels are very quiet anyway, the newer ones, as far as exhaust note, unless you delete them. So being as the modern diesels have so much emissions equipment on there that muffles them, they don't need a muffler at all. And that's one of those things too, where people delete all this stuff, and then the truck makes all kinds of noise and everything else. I understand it's not quite the same as a car, but I'm still not entirely sure why you want to make all that noise out of your truck that you're driving around everywhere. I have a MagnaFlow performance muffler on my gas pickup. And I think there's a time and a place for that kind of stuff. I really do. You know, part of the purpose of a muffler is to be a spark arrestor. So if it's a spark arrestor and you're out in the sticks, you might be setting fires, and that's no good either. So as you can see, we're still burning that off to make sure it's all gone. And it'll finish up here in just a minute. But this is a ceramic catalyst, and they want to make sure they don't crack it, so they bring it up fairly slowly, and then they're probably going to let it down the same way. But they want to make sure that they've got everything super hot all the way out to the back, and that their differential pressure sensor is actually accurate. When we're doing this, just keep in mind that, you know, I'm in the closed cab with all the windows up, and you can sure still hear what the engine is doing. So, because what they do is they lock that fan on 100%, and they just get after it. So, one more thing to keep in mind, as it were. I think it's funny how they say it'll take 20 minutes, and it's of course it's been longer than that. It always is. It's this particular test, if you want to call it that, the service regeneration, this process, right, this output control, always seems like it takes forever. And there's your NOx concentration again, and your O2 concentration. Okay, did you hear the change in the engine note? And you saw that this went back up to 14%. So what that means is they stopped injecting fuel. See, 0. And now what we're doing is we're running the truck at about 2,000 RPM, and we're going to go ahead and pump air through that whole exhaust until it cools off to a certain extent, and then the regen's over with. So let's see, did it count? It did count. See right here, 125 successful regenerations. Ta-da! Okay, and now see, now we're back to running the def, because we've got 100 in and we've got 20 out. That's great. So there you go, and all of this is at 0. Okay. Particulate filter pressure is down to 0.4 now that we've brought it down to about 1600 RPM. We're at 0 grams, all of that good stuff. And boy, does it smell lovely. Okay, we've got that off. See, and we're still at 1,000 degrees coming out of that DPF. So at that point, we need to cool off all of this emissions equipment, and that's why we're running the RPM up at 1600 to pump enough cool exhaust through there to get that taken care of. Curious to look at something over here. Okay. Yeah, so you can see that this is starting to come down now to 475 degrees, just higher, just slightly higher than the temp coming in, which is where it belongs, right? If it's actually working. And then EGT3 is coming down and EGT4 is starting to come down. But it takes a long time. It takes a while to build up all that heat. So, and they don't want to, like we talked about, we don't want to rush it because all this stuff is ceramic monolith. And when you do that, if you rush it to heat, then what happens is it cracks. And once it cracks, it's no good. That's why you hear a lot of these catalytic converters where it goes rattle, 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 rattle inside. And that's because the monolith has broken loose from its mounts and it's cruising around inside the casing. And sometimes it'll block the exhaust pipe and cause a low power concern. So it's marching on down, but we're still at 1600 RPM. So it will still keep pumping fresh air. Essentially, it's exhaust at this point, but there's more air than there is exhaust at this point because we've turned off that after treatment injector, and it's going to march these sensors down to a set threshold, and then it'll let them cool off naturally. This is something I usually, yeah, there it went. Now we're back to 700. There we go. See? And you can see where this is still pretty warm, you know, 660 degrees coming out EGT sensor 4. So, at any rate, and it showed that complete before. Yeah, and there we go. See, now we're at a point where that the DEF fluid has 100% gotten a hold of that. So the O2 concentration is lower here because we're doing our conversion, right? And then there's our 43 parts per million in and 0 parts per million coming out. So that's good news, huh? And now it's starting to count again since the last time we just did it, which of course was just now. But it keeps track of all of this. It's really, so now we have no PSI at idle, essentially. Our DPF pressure sensor's at 1 volt, and our soot mass is at 0. Okay, so that's all. It's all pretty important. So we're down to 700 degrees, and we're still, you can see that it's still in a commanded on state. So when it's totally finished and it finishes cooling off this emissions equipment, that will switch to off or none, and then it'll be all over with. So pretty cool stuff. I was just talking with Miss Ashley, who you guys know from the tool room, and she was saying that with, because she works over at Jaguar, she was saying that there's no way for them to force the Jaguars into a regenerative state. What they have to do is put it out on the highway for 60 miles. I thought that was pretty wild. I didn't know why you would not do that, but apparently you don't. Apparently Jag doesn't care about that. So at any rate, so we're just winding it down now. You can see too where the cat's starting to do some work again, where this has picked up some. So we're actually cleaning up emissions that are coming out of the truck now. So because the HC injector right here is still inactive, right? So it is actually doing its job now. And the rest of the stuff is cooling off, and it'll kick down to a 600 RPM idle here in a couple of minutes after it finishes. Still at 0 grams, 0 PSI. And it's still counting. See, we're up to 0.05 hours runtime. Since it finished its regeneration, we're still at 125 regens. So that's good news. Ta-da. And NOx is being converted, so that's good news. Yeah, see, the engine speed's still up at 800, which is a little bit high, and we're doing that so that the engine and the exhaust can cool down. So you can see, even with the hood open, the IAT is at 122 degrees Fahrenheit. That is just absolutely silly when you look at the exterior temperature being, I think, about 50 degrees. Yeah, 56 degrees is what the truck says out front, so that's probably fairly accurate, since it's drawn about 80,000 cubic feet of air across that radiator trying to keep the damn thing cool while we're doing this regen. So yeah, so that's interesting stuff. There's our engine load, which is almost nothing at this point. We're still running a little bit of boost here, see that? And you can see the idle air flow valve is at 0. So we instead of it being partially closed to warm the truck up, now we're all the way open, aren't we? So we've got 0 restriction for that air coming in, and even at idle, we're building just a hair's worth of boost. Just a hair's worth. So there's all of that. Okay, and we've turned off post injection. That's what I wondered. We had post injection active for a while, and post injection also helps heat up the cat. So that's what they were doing with that. So they were doing, so if you were to watch the pulse, it would be pulse, 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 main injection pulse. So we would have pilot, 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 main, and then it would be after the next stroke on the exhaust stroke, and then it would give you a little post injection. So that's what they're doing with that. And you can see too that we've used 5% of our fuel. That's not insignificant. You know, we were at 3/8 of a tank before we started, and right now we're just above a quarter. So there you have it. So anyway, let's go back over here, because we're still at about 800 RPM, so it's still cooling things down. So let's go take a look and see what our temperatures are. Yeah, see, they're normalizing, but it takes a long time to get rid of all that heat. It takes a long time to cool things off to the point that the truck decides it's okay to just idle anymore at 500. So, and they actually specifically warn you that, you know, the truck may surge and things like that. It stops when it's in a regen mode. Because they have to keep, even if it's doing it while you're driving, they still have to keep that idle up at a stop, because they need to keep things hot inside that pipe. So sometimes if you stop long enough, it will shut down the process and it will return to it later. Like I said, I hate to do that. I usually try to drive all the way to the end if it's doing it. Or I'll pull up in front of my driveway and just run it at 2,500 RPM for a little while until it finishes its regen. That way it's done and over with. That's my thought. That way it doesn't keep trying to burn a bunch of extra fuel over and over and over and over again. So it's coming down little by little. You can also see that the commanded state is still on. It hasn't technically finished, and that's because it doesn't like the EGTs that it's seeing. But you can see here, you know, it's interesting. We always talk about how hot diesels run and everything, and we were running 600 degrees during that test, right, at the back of the turbo. Well, the thing is, you don't want to run more than about 1200 or 1250. Okay, so we just dropped. Okay, we just dropped. We're at 600 again. So now it's going to shift over to off here in a second once it's ready. But it's complete. We could shut the truck down now if we wanted to. See, 640 is our desired idle. So big difference. ECT's only at 177, which is good. It doesn't, I mean, they don't need it to run any hotter than that as a rule, so it's in pretty good shape. Just depends on how hard you're working it, where that's going to wind up running. And you can see the IAT is, or it was, yeah, it's still bouncing a little bit. It's starting to come down now that the under hood temperature is starting to fall. So there you go. We're still running just a tiny amount of boost, and all of that's inactive now. So that's a regen for you, but you can see this now we're down to 418 and falling, so that's good news. So at any rate, we were talking about diesels and how hot they run. I was talking with my uncle, who was an over-the-road trucker for longer than I've been alive, and he always said that the way they tuned them, if you were running more than about 1200 degrees, you're just wasting fuel. It sort of depends. On a stock vehicle, that's true, and right around 1250 is where people start to get really worried about burning up pistons and rings and things like that. So that's one of those deals where you really have to watch what you're doing when you're tuning. And I actually bought the tuning package for this truck, and the reason I did that was because the guy that developed it owned this truck specifically with this powertrain just 2 years older. He bought one of the first Denali's that came out, and then he went ahead and tuned his truck, and he tuned it for drivability, and that made all the difference to me. You can make huge power, but you can't always make huge power and drivability live in the same environment, and that was his goal. So he was more after peak drivability with peak power. So that's how he tuned his truck. So he would make a couple of changes and drive it for 2 weeks, and then make a couple of more changes and drive it for 2 weeks. And it took him 6 months to put the tuning package together, and he did a whole bunch of stuff on the dyno as well. So, I mean, he's really, really, really thorough. DuramaxTuner.com if you want to go visit his site. Nick Pregnitz. Smart dude. But the biggest thing that he did that I liked, that I wanted, was he tuned his truck with the entire emissions package in place and didn't destroy it. And that was what I wanted. I wanted to be able to not have to worry about emissions because all of my stuff was intact. I wanted it to run clean. I wanted it to pass a test with a tune in it, which it does. And I didn't want to have to worry about the integrity of and the engine or the trans or anything else. So everything on his truck was stock. He just tuned the engine for more power within the limits of the transmission and the emissions package. Now, since then, he's gone after peak power, and he actually came up with a compound kit that I almost bought. I almost bought the compound turbo kit that he offered, and then I decided I probably didn't need it, because the other thing too is once you get to compound turbos, you start to get to a point where it makes so much power that you have to do things like upgrade the transmission. Well, the Allison is already an incredibly stout unit, so if you have to upgrade that sucker, What do you really need all that power for? That's the next question. What are you using it for, right? So there you go. Alrighty. So everything's returned to normal. We're all good to go. It's completed its deal. Everything, all of this stuff is coming down and or normalized. So I think we're good to go. I'm gonna go ahead and turn this off. We'll just press exit. Ta-da, commanded state none. Rock and roll. Now, if you listen to the engine note, it did pick up a little bit because it's still trying to shed some of this heat here. That's what it's doing. So it will idle up for just a little bit. It's at 1,000 RPM right now. It wants to get rid of the heat in that emissions package. So that's what it's doing. So it's idled way up. So whatever it was doing, it wasn't done. So it's still thinking about it here. Okay, well, you exit output controls and then it kicked it all out. Still up at about 800, so it's still sorting its life out here. But it never turned the injector on, so I'm not entirely sure what it was doing. So we've got 157 meters cubed per hour for exhaust. Our DPF measured soot mass is at 2 grams. Got all of our information there. We're still reducing NOx. We're down to 9 parts per million from 200, so that's pretty good. Engine speed, MAF sensor, map. We're still doing a little bit of boost right here. So let's see. Been running the truck for an hour. See, that's why they say 20 minutes, and I usually call BS on that because I've never seen it only take 20 minutes in my life. Let's see, let's go and try something else. So what I'm looking at right here is pilot injector balance procedure. What that's doing, if you guys look right here, so it says like positive a little bit, like positive 0.8, negative 0.7, blah, blah, blah. So what that is that's the amount of fuel, high or low, from a center line that's programmed into this thing that it takes to keep the engine running smoothly. Now we had some people that went through that. Remember, we had positive -4 in park or neutral, and then we had positive or -6. And when I say 6, I don't mean 0.6, I mean 6 whole millimeters. That's a whole lot of fuel, cubic millimeters. That's a whole lot of fuel for one cylinder to try to balance it out. Now my truck runs great, and I tend to treat the fuel and keep things clean, so I don't have that issue, which is good. But you will see trucks out there that have an iffy amount, of whether they're plugged up or they're leaking, one of the two. I was just curious to see if see, and there's the power balance. I was just looking to see, actually, I wanted to see if I could turn off the pilot injection so you guys could hear this thing rattle when it runs, but I don't know if I can. I don't see a way to do that, which is too bad, because I mean, you guys can go online and listen, and you probably can hear it in some of the older trucks just starting up, and then you hear the rattle, right? Let's see, injector data, let's try that. But we were talking about how GM pioneered this in class. Okay, so the pilot injection is commanded on. Base fuel injector rate is between 8 and 9 millimeters per injector. Okay, so 0.3 milliseconds. Remember, we were talking about rail pressure and what the difference is in pressure versus fuel quantity delivery, right? So the higher the pressure, the more fuel we deliver. So we're used to looking at gasoline engines, right, on port fuel cars, which is what you guys have done with your labs, right? And what you've wound up with is, oh, well, they're on for 2.5 to 5 milliseconds or something like that, depending on whether or not you're under load. Well, if you look at this at idle, we're running about 6,000 psi. Let's see if it'll tell us. Yeah, 5,000 psi right here in that rail, and our injector rate is 0.3 milliseconds, or 0.3 seconds. So 0.36 milliseconds. A whole lot of not much. We're not even up to 1 millisecond yet. And the truck finally satisfied itself. It finally settled down. So it was gonna run till then, cooling things off before it shut up. So I stopped it a little prematurely, but it went ahead and finished its procedure anyway. That's what will happen. That's one of the reasons I let it run. So, and then your injection timing is here, right before it gets to the top, right? 0.2 degrees. That's pretty damn accurate, isn't it? Right? So, let's see. Injector timing is at 0 degrees. That's your negative 0.2, negative 0.1. That's your timing in degrees right before that piston reaches top dead center to make it burn properly. And then this is how much it's taking out for balance rates or adding. Like this one is almost 1 cubic millimeter high, whereas this one is almost 1 cubic millimeter low. So this one's putting in too much fuel, that one's not putting in enough. Luckily it's right close to 0. It's well within specs, so we're good to go. At any rate, seeing now we've idled down and we don't need as much fuel pressure, we're at 4,000 psi just at idle. So at any rate, hope you guys enjoyed the video, and hit me up with any questions, and we'll talk to you later. Have a great day. Bye.